This is Unit 4, Lesson 2, Proportions. What is a proportion? Well, when two ratios, now what's a ratio? Well, a ratio is a comparison of numbers in a fraction. So think about it as two fractions. When two ratios are set equal to one another, they form a proportion. Here's an example. 4/10 is equal to 2/5. Those are two ratios. Numbers expressed as fractions are set equal to each other. Proportions are handy in that if we have two ratios and we're missing one of the values, we can use our proportional relationship to solve to figure out the missing value. You might be more familiar with using the word proportion when in everyday life when you say something's proportional. Here's an example. Here's a 69 Camaro. If you were going to build a model car, you would want that model to be proportional. That is, the ratio of the dimensions needs to be the same for the car and the model. If you didn't have equal ratios, your model would end up looking pretty funny. It would be out of proportion. Another way that we use proportions is when we're creating maps. We want the map to represent the actual distances in a way that makes them look equivalent to what they are in real life. So we use the scale on the map. That's something that's proportional. The distances on the map are the same ratio as the distances in real life. So let's go ahead and example 1. We're going to solve for the missing value x in this proportion. One way we can do it is we can think of the fractions as being equivalent. 4/10 is going to be equivalent to some other fraction with the denominator of 30ths. So if we were going to take that original fraction, we could say, well, what would you need to do to 10 to make it go into 30ths to create an equivalent fraction? We would need to multiply 10 by 3 to get 30. So we could do the same in the numerator. We would multiply 4 by 3 to get 12. Therefore, we know the value of x would need to be 12 for that to be a proportion. Now here's another example, but you can see it's not so easy to turn 10 into 25, so we're going to have to use a different method. So we might decide, let's make common denominators. So I'd like you to not write anything just yet, just watch for right now. What if we wanted those fractions to be equivalent fractions as though we were adding them together with a common denominator? Well, we could do that, and then it would be much easier to compare the numerators. So to make a common denominator with 10 and 25, we could multiply the two together and get 250. So if we were going to make 4/10 into 250ths, we'd multiply by 25 over 25, and that would give us 100 over 250. And then if we were going to change x over 25 into 250ths, and we would multiply by 10 over 10, and that would give us 10x over 250. So now we can compare much more easily since they're both out of 250. We can just compare those numerators. That means that 100 is going to be the same as 10x. Well, there's a nice little algebra equation that we can solve by dividing each side by 10 to get that x by itself, and that would tell us that the value of x would need to be 10. So let's take a look at that process. We're still not going to be writing anything. Just watch. Think about what we did. Remember, the denominator ended up being 250. So we were sort of ignoring that and just paying attention to the numerator part. So I'm going to write that again down here, and let's see what really happened. We were multiplying 4 times 25 in the numerator, and you can see that we've got 4 and we've got 25. One is the numerator of the first fraction, and the 25 is the denominator of the second fraction. And then we multiplied x by 10, and you can see that we've got x and 10 as the numerator and the denominator on the other parts. So this is a process that's called cross multiplication. We take the numerator of the first fraction and multiply by the denominator of the second fraction. And then we take the denominator of the first and multiply by the numerator of the second. So let's go ahead and do that in this example. Now I want you to write. So here's our proportion, and we can't go from one to the next very easily just making equivalent fractions, so we're going to use that process of cross multiplication. We're going to take 4 times 25, and we're going to write that down, 4 times 25. And that's going to be equal to 10 times x. So we're going to write equals 10 times x. Now, we've got an algebra equation, and we can solve that. The first thing we need to do is simplify. 4 times 25, do that multiplication, and write 100. Now we want to get x by itself. So we want to isolate x, and there's a 10 with it. So we're going to divide each side by 10, and we get 10 equals x, and then we're going to write that in the other direction, x equals 10. So there we've solved it using cross multiplication. All right, let's do another example. And remember to write each step just like I've written. This is a model for exactly how we want you to be doing it on your homework and on assessments. So we're going to cross multiply. The first step is multiply 8 times x, the numerator times the denominator. We get 8x, and then we're going to multiply 14 times 10, 14 times 10. Now we're going to continue to solve, so we're going to write 8x. 14 times 10 is 140. We want to get x by itself, so we divide each side by 8. That gives us x equals 17.5. All right, number 4, I want you to try it. Pause the video, give it a try, and then come back and see how you did. All right, here we go. We're going to cross multiply 6 times 25. That's going to be equal to x times 10, and we're going to write that with the 10 first as a coefficient, 10 times x. Now we're going to simplify. 6 times 25, 150, divide each side by 10, x equals 15. Example 5. Now we've got a problem. You're going to see that sometimes problems are very easily solved using proportions. Suppose you can buy 2 CDs for $25. At that rate, how much would it cost to buy 7 CDs? So our first step, of course, is to define our variable. What is it that we don't know? We don't know the cost of 7 CDs. So that's our variable. Go ahead and write that down. Now we're going to set up a proportion to solve this. And we're going to make the ratio the number of CDs over the cost of CDs. So we're going to set our first ratio with some information that we know. It tells us a complete ratio. 2 CDs cost $25. So we're going to write that exactly like we have here. The number of CDs is 2, and the cost of the CDs is 25. We write one ratio that way. And then we're going to set that equal to the other ratio, but we don't know all the information in that ratio. It's asking about 7 CDs, but we don't know the cost. So we're going to use our variable and the 7 to set it up in a proportion equal to, so 7 CDs, don't know the cost, 7 over x. Here we go. We've got a beautiful algebra equation that happens to be a proportion. So we're going to cross multiply. 2 times x equals 7 times 25, or 25 times 7. Now we're going to solve for x by doing all that work. 2x equals 175. Divide each side by 2. We get x equals 87.5. And we're going to make that look like money and add that extra 0 at the end. So then we're going to write our answer in a sentence. It will cost $87.50 to buy 7 CDs. Again, be sure to write all of this down. This is exactly how you should be doing your work when we do problems in class and on assessments. Example 6, give it a try. Pause the video, give it a try, see how you do. All right, let's see how it went. Here is our work. Make sure that you have everything written down this way. Define your variables, set up your proportion, solve your proportion, and answer in a sentence. All right, I want to talk to you a little bit more about this one because it might be that your work looked different from mine. When I set it up, I put time over people. And so I ended up with this proportion. But nothing says that you have to write 20 over 160 first. You might have written it in the other direction with 20 over 160 as the second one. You can see that when you cross multiply, the order is slightly different, but it's still 20 times 220 and 160 times x. So it doesn't matter if it comes out flip-flopped in the other direction. In addition, we could have written people over time. You can see that proportion set up. gives us the same cross multiplication. So even if we have people over time, the ratios end up producing the same cross multiplication, so that's still a correct proportion. And again, that might have been flip-flopped with them on either side in the different direction, and we still get all the same cross multiplication. So if you set up a proportion and the cross multiplication ends up the same as mine, you know that it is correct. Now, here's actually even another way that we could have done it. Instead of having our people and our minutes in the rows, we might have had the time and the people in the columns. So here you can see it's set up with columns instead of rows being defined that way. And you can see that you could have put people and time flip-flopped the other way, and we would still get the same cross multiplication. So just know that when you're checking your answer, say if you're checking on the quiz prep worksheet or the study guide, that it's possible your proportion looks different from mine. Just double check that the cross multiplication is similar, and then you'll be okay. That's it. Put your note sheet in your binder. I'll see you tomorrow.